All right, today we are revisiting piecewise functions. So we worked on piecewise functions with our linear functions at the beginning of the year with our absolute value. Now they're back, but today we want to be able to create and graph piecewise functions with both linear, as we've done in the past, and quadratic pieces, now that we've talked about how to build their equations and some of that behavior. So we're going to start with the same thing we started with linear. So we're looking at functions here. We're given a piecewise function, right? It's broken into pieces. Remember, their domains are restricted so that they're not overlapping. This one's going when x is, for values x is less than 0, we use this function. Values 0 to 3, we use this function. X is greater than 3, we would use this piece, right? So we've got our piecewise function. So let's just start off with reviewing how to evaluate. First of all, we look at the function it's asking us to find. So we're looking at g. So we're going to come over here to the function on the right. This is g, and then we're finding, well, where would 3 fit into those restricted domains? Is 3 greater than 2, or is 3 less than or equal to 2? Well, it's not less than or equal to 2, so we're going to use this piece right here, 2x plus 5, to evaluate the function. So where there's an x, we put that 3 in. And we can evaluate this. 2 times 3 is 6, plus 5 is equal to 11. That means at 3, the function output is 11. F of 0, so again, we choose the f function on this one. So we're going to come over here to this left function, and we're looking at f of 0. So notice here, the first piece is where x is less than 0, but we want it to be equal to 0, so we've got to choose this piece where it's less than or equal to 0. So this function is 2, and it's 2 no matter what, because there's no x value to put in. So we're there. G of negative 10, again, if we look over at the g function, negative 10 is not greater than 2, so we're not using the top piece. Negative 10 is less than or equal to 2. So we are going to go ahead and use that bottom piece. We're going to put negative 10 in, square that, and then minus 1. So negative 10 squared is a positive 100. Remember, anytime you square a value, it's a positive, and then we subtract 1, so this would equal 99. Okay, evaluating functions. And we practiced that so that we could use it as we were graphing functions. So remember, when we're graphing a piecewise function, they are restricted between those barriers, and we kind of talked about, notice this one, if we graph h of x, the first barrier there was like at negative 2. So we can think about a barrier staying at negative 2, and the first piece has to stay in its own zone, so it has to stay over here. One thing I would like us to do is change. I know this says x cubed here. Let's change this to x squared, just because I want us to practice with quadratic functions. So go ahead and change that. I don't know if you noticed right there, to an x squared plus 2. From there, again, we kind of drew in our little barriers, so I'm going to do it with kind of blue. Here's a barrier right there. Kind of hard to see, but essentially we're saying one of them's at negative 2, and the other one, notice this goes from negative 2 to 1. So the other one is going to be at positive 1. So we've got 3 pieces. One of them has to fit on the left side of the barrier, one between the barriers, and one on the right side. So with our linear functions, if you look at this first one, notice that is linear, x minus 4. All we did is we said, okay, well, let's take the domain value and figure out where that is going to hit the barrier. So if we put negative 2 in, minus 4, right, to this piece, we end up with negative 6. So on that barrier, we're going to be down at negative 1, 2, 3, 4, 5, 6. And it looks like that's less than negative 2, not including, so we're going to do an open circle there. Now again, we just count with our slope. So the slope here is 1 over 1. So I could go up 1 over 1, up 1 over 1, but that's going to go right into my barrier. So I need to go down 1 over 1, down 1 over 1, so that it heads this direction. So we're going to go down 1 over 1 and draw our linear function there. Okay, that's the left piece. Then we move to the middle piece. Now there's 2 ways you can do this. One, you can just plug in values. The second is we can go off of what we've been practicing with our quadratic functions. So you'll notice this piece right here is x squared plus 2. Well, we know that x squared usually sits at the origin and goes up by perfect squares. This hasn't been stretched or shrunk at all. It just shifted up 2. So we're going to be up here at 2 and then go up by perfect squares. And of course, it's going to hit barriers on either side of that, so we'll have to stop graphing as we go. So again, I'm going to go ahead and shift up 2, so I know that this is sitting right here. And that's just a piece on the graph, on the parabola. And then again, it's going to go up by perfect squares. So if I'm 1 unit away from the vertex, it's going up 1 unit. So we keep it symmetric. If I'm 2 units away from the vertex, it's going up. Oh, I drew that barrier on the wrong spot. Oh, I don't have you guys in class to tell me it's in the wrong spot. I apologize. That barrier's at +1. This graph's squished right in there. Okay, awesome. So when I'm graphing this parabola, and the reason I noticed that is I noticed that this should be an open circle right there on 1. So my parabola hits it right there, and then moving to the left, again, if I'm 2 units away from the vertex, 2 squared is 4. So I'm 4 units up, and it looks like it's closed on this end. So notice if I start connecting these dots, it's just a piece of the parabola that would be there because we've restricted its domain. Okay. Now again, it's pretty easy to do with something like that if the parabola is just shifted up or down. Notice this third piece may be shifted all over the place. It may be shifted left or right because it has a middle term. So we can just plug values in. So I want to show you that as well. So remember, it's going to hit the barrier at this value. So let's start at +1. And maybe I'll make a little table just to keep track of my values. So I'm going to put a +1 in here. So 1 squared is 1 times 2. That's just 2 minus 4 plus 2. That looks like it's going to give me 0. Right? So I know that on my graph, I'm at +1, I'm at 0, and that's in a closed circle. So right there on the graph. And then I just want to figure out what the behavior of the function over here is. So then maybe I'm going to choose +2 and plug it in, and +3. And then quadratics go off the graph pretty quick, so I can kind of figure out where those points would be. So again, if I come up here, maybe I just choose +2, right? And then I go ahead and plug 2 in. And again, I evaluate. So 2 squared is 4 times 2 is 8. -4 times 2 is -8 plus 2. So 8 minus 8 is 0. That just gives me a +2. So I'm going up 2. And then let's say we want to find one more point. So I'm going to plug a 3 in. So let's do, 2 times. Put that in the barrier so I don't confuse that. 4 times 3 plus 2. 3 squared is 9 times 2 is 18. -4 times 3 is -12 plus 2. So 18 minus 12 is 6 plus 2 is 8. So I'm just plotting this point. So at 3, I'm going to be up 1, 2, 3, 4, 5, 6, 7, 8. And that just gives me a few points to get to draw my parabola or the shape of that piece off of. So notice it passes the vertical line test. I have a linear function over here on this side of the barrier, and then this parabola ends within the barriers, and then this one heads off this direction. So we just want to make sure it passes that vertical line test. All right, let's try one more of these. So again, this one only has 2 pieces. Oh, it doesn't even have a name. Let's call them f of x. It has 2 pieces here, and let's draw our barriers. Let's do some orange. Our barrier here at 2. So it looks like there's our barrier. And we want to start with either piece. It looks like this is x is greater than 2. So let's just plug this 2 in. That's going to be on the right side of the barrier. So we'd have 2 times 2 plus 5. 4 plus 5 is 9. So right here on the barrier, we're going to have an open circle at 9. And then again, our slope on this one is 2 or 2 over 1. So I'm going to rise 2, run 1, and then draw my graph headed off that direction. Then for the next piece, again, we can plug in values, or again, look at this piece. Notice it hasn't been stretched or shrunk. It just got shifted down 1, that vertex. So I'm going to go down 1 on the y-axis, and I'm going to put it here, and then it goes up by perfect squares. So if I'm 1 unit away, it's going to go up 1. If I'm 2 units away, it's going up 4 from the vertex. And notice that hits the barrier right there. So I'm going to stop on that side. And on the right side, again, there's a point. And if I'm 3 units away from the vertex, then I'm 9 units up from the vertex. So here I can draw this parabola. Hopefully it looks like a parabola. And there's our 2 pieces. So there's our quadratic function. All right, then creating the function. So on the back page, we're given some different functions here. I'm going to jump to the ones that are quadratic specific. So there's a linear one that we could do up there. Let's do graph number 2. So again, remember when we build a function, you can call it whatever you'd like to. We just use correct function notation. We use these braces to represent a set of functions. So, or set of equations that creates this function. So we can start on the left or the right. Maybe let's start on the left and we look at this first barrier is here at -2, and then this line heads off this direction. So this first piece is going to be where x is less than -2. Okay. The next piece you'll notice is sandwiched between that barrier at -2 and then +1. So there's another barrier where those pieces split. So we could sandwich this next one between -2 and +1. Notice it's a closed circle on the left of that parabola piece and open on the right. And then the last piece is just where x is greater than 1. So again, on the left, these are something that we've already worked on. We just need to write the linear equation. Remember, linear equations are mx plus b, where we need the slope and the y-intercept. So our slope here, if we count this down, it looks like it's going down to right 1. So this is -2x. And if we were to keep going down 2/1, it looks like it would cross at -4. So we're going to have -4 here. And we're done with that piece. The next piece in the center here is the parabola. So notice, the first thing I want to notice is if it's stretched or shrunk at all. Notice here's my vertex and it's going over 1, up 1. So it's going up by perfect squares. This hasn't been stretched or shrunk at all, so we know that it's x squared. It's also just moved down 2, right? It didn't move right or left at all, so we just know that it's x squared minus 2. Now again, if you were stuck, you could use any of the methods that we practice with creating quadratic equations with this. Whether it's calculator or vertex method, those two, I guess, would be feasible on this one. And then our last piece is just a flat line at +2, so we know that the last equation would just be a 2. Okay, and again, if I wanted to find domain and range on this, just because you will practice that on your assignment, remember domain moves from left to right. So notice there's an arrow headed this direction, so that means that the graph's going to go forever over here. So from -infinity, it looks like there's no holes in the graph and it'll go forever this way. So to +infinity, our domain is all real numbers. The range moves from bottom to top. So if you look at our graph, there's no graphs down here. So the first y value that even starts with our graphs is -2. And then notice this arrow's headed up forever, and there's no holes in our range. There's always a graph going up forever and ever. So we would start at -2 and we would go up forever. All right, let's look at graph 4. Also a parabolic piece on this one and a couple linear pieces. So again, we write our function over here. Let's call this one c of x. And we can just start with the left piece. Again, let's look at our barriers. So notice this guy right here, -1 is the first barrier, and then it looks like there's another barrier at 2. So the first piece is always less than -1. And this arrow we're going to assume is headed off into a direction since there's not a closed or open circle there. The middle piece then is sandwiched between -1 with a closed circle on each side, and it's sandwiched between -1 and +2, and then where x is greater than 2. All right, let's look at our line. So the first one's linear. Again, we want an mx plus b, so we need a slope. So we go ahead and count. It looks like if I start down here, it goes up 1/1, right? Or we guess we could look at it like this, but since our graph's going with huge blocks, up 1/1, so we got a slope of 1, so it's like 1x. If it keeps going up 1/1, it looks like it's going to cross at 3, so that would be +3. So this first piece, it looks like, would be an x plus 3. From there, we move to the next piece. So again, if you look at this quadratic piece, it hasn't left the origin, so that's good. We don't have to shift it anywhere. And then notice it's going up 1/1, so it's keeping that perfect square form, which means it hasn't been stretched or shrunk, so we're just looking at the graph of x squared. And then lastly, we've got a flat line at a positive 2 once again. So the goal with this really is you can create equations using any of the methods that we talked about, and it can be in any form. If you want to write it in vertex form right here or standard form, any of them are fair game. You just have to make sure that it's not missing any pieces. So if it's been shifted up or down, make sure it's there. Other than that, I will post a partial key, and you can work through the homework and just practice. If you have questions, we'll go over them